Hey guys, Mr. Wilson here. Today we're going to talk about adding and subtracting polynomials. At the end of this video, you should be able to add and subtract polynomials. Alright, so here are a couple tips. Before you start adding and subtracting, make sure that you put both polynomials in standard form first. And then make sure you have a way to identify your like terms. Okay, here's a method. Here are two methods that will help you to identify your like terms. Okay, we have a 4x squared plus 6x plus 7 plus 2x squared minus 9x plus 1. So that's one addition problem. And we're going to show you two methods. We have the vertical method. The advantage for the vertical method is less thinking. Okay, and here's what you do for the vertical method. Line up like exponents, add and subtract the coefficients, and the exponents never change. Okay. The rule that I found works in math is if the exponents have to be the same, the exponents have to stay the same. Okay, so here's how we do this problem. We have 4x squared plus 6x plus 7. Our second term, instead of having it horizontal, we'll just line it up. 2x squared minus 9x plus 1. And so by lining this up, we're able to just go straight through and do the problem. We have 6x squared. Again, these don't change. They had to be the same for us to put them together, so they stay the same. 6x minus 9x, negative 3x. 7 plus 1, 8. Okay? And so there's our answer. 6x squared minus 3x plus 8. Horizontal method, the advantage is probably that it's going to be written that way and less writing. Okay, you don't have to, or less space maybe, I don't know. Okay. So, here are some tips. Identify and mark like terms. Add and subtract the coefficients. Exponents don't change. Again, that rule. If they have to be the same, they have to stay the same. Okay, so here we go. I'm just going to do it from here. I see 4x squared and 2x squared. 4 plus 2, 6x squared. I see positive 6x and negative 9x. When you do this, make sure you include that sign in front of it. So positive 6 minus 9 is negative 3x. I see plus 7 and plus 1, plus 8. Notice that our answer is not different. Okay, try that out. Whichever method you like, whether you like the vertical method or you like the horizontal method, try that for this last problem. Okay, so we've talked about addition, and now let's look at subtracting polynomials. We really don't subtract. What we'll do is we will flip every sign. There we go, let's say that. Switch every sign in the second parentheses. It says equation. It should say parentheses. And the problem becomes an addition problem. Okay. So in the second parentheses only, not the first parentheses. Why does this work? The minus sign is a negative 1 in front of the second. Again, I say equation, but it's not really an equation. It should be expression. Okay, and therefore you are distributing a negative 1 to the second equation, which flips the sign. So this is how it will work. When we have this problem, 2x cubed plus 5x squared minus 3x minus x cubed minus x squared plus 1, we'll say, okay, well, let's not do the minus. Let's make this, distribute this negative 1 to all terms. So we have 2x cubed plus 5x squared minus 3x. And then I distributed that negative, so now I can change it to an addition problem and say plus negative x cubed plus 8x squared plus 11. Now notice here that because there's no x here, I'm not going to line it up with 3x. I can make a space saver and just write 0x. Okay. And this is how we set it up vertically. And so now I have an addition problem that I can do easily. With all my like terms lined up, 2 minus 1 gives us 1x cubed. 5x squared plus 8x squared gives us 13x squared. 5 plus 8. Negative 3 plus 0, negative 3x, 0 plus 11, plus 11. And so there we have it. Again, we changed the subtraction problem into an addition problem. Okay. Try the difference here for this problem. Try to do that, distribute that negative 1, put your like terms together, whether you try to do the vertical method or the horizontal method, doesn't matter to me. And then find the answer there. Okay. Bottom here it says the perimeter of the figure shown below is 25c plus 9. Write an expression to represent this last side. So, perimeter, that means that we're adding up the lengths of the outside. And then they already gave us the total. They told us the total is 25c plus 9. So we need to find this missing side. And what we'll want to do is we'll want to find out what we have already. So now I'm going to take these terms and put them together. And what I'm going to do is I'm just going to identify all the like terms. 11c plus 6c is 17c, plus 3c is 20c. So I have 20c, negative 4, positive 7, that should give me positive 3. Okay? Now, what I know is that I'm missing this side. Okay, and it should add up to 25c plus 9. And so I can do a couple things here. I'm going to subtract to find the difference, because this is going to be the difference between these two. I'm going to say, okay, 25c plus 9. This missing side should be the difference between 20c and positive 3. And now here's why we want to make sure that we do make it an addition problem. Okay? Because what a lot of people will do is they'll set this up as 25c plus 9 minus 20 plus 3. Okay? And so when you do this vertically, a lot of people will get 5c plus 12. But what we're going to do is we're going to make this an addition problem before I do it. Okay? So, how this helps us is now that we've distributed this negative, we have 25c plus 9. I'm going to distribute this negative 1, so I have minus 20c. Distribute this negative 1, I have minus 3. Okay, and now I'll find my like terms, 25c, negative 20c. Positive 9, negative 3. Put these together. 25c minus 20c gives us 5c. Positive 9 minus 3 gives us 6, plus a positive 6. Okay, so there you have it, adding and subtracting polynomials. Make sure that you line up your like terms. You can use the vertical method or the horizontal method. And remember that we really don't subtract, we change subtraction problems to addition problems, which we can do by distributing the negative 1 to each term in the parentheses. Okay? Alright, see ya.